Hi guys, my name is Melissa and today we're going to be doing addition and subtraction of fractions. And so right now we're going to talk about adding mixed numbers. And so last class we talked about mixed numbers and how to change from improper fractions to mixed numbers and how to change from mixed numbers to improper fractions. But we haven't really talked specifically about how to add fractions, especially about how to add mixed numbers. And so we're going to go over how to add and subtract mixed numbers today.
So for fraction, it looks like this. So a, the number at the top, is called numerator, and the number at the bottom is called denominator. And so a fraction is basically when we divide something by something. And so a is the number that's being divided, and b is the number that is dividing. So for example, if we're going to divide 42 by 8, a is 42 and b is going to be 8. And also, we're going to go over concepts of where we have to compare two fractions. And so if we have the same, for example, if we have a, c, and b is the denominator. So this is a scenario where the denominator is the same. So it's same denominator. But then the numerator is different. And in this case, a is greater than c. Then that means that this fraction is bigger. So when the denominator is the same, the fraction with the larger numerator, so the larger top number, is going to be larger. And that is because we're dividing a larger amount by the same amount. So for example, let's think of it as this. So since the numerator, or the number at the top, is the number that's being divided, let's say we have 20 apples and 10 apples. And b, or the denominator, is the number that is dividing. So we're dividing by b. We're dividing by the denominator. So let's say we're dividing by 2. So we're dividing by 2 because let's say we have 20 candies and 10 candies. And we want to give 2 candies per person. Then since we are dividing by 2, we know that we can give 10 people candies, because we're giving 2 candies per person, and so we can give candies to 10 people. But on the other hand, we can only give candies to 5 people because we're dividing by 2. And so this is smaller. So basically for the results, when the numerator is bigger and the denominator is the same, then the fraction with the larger numerator is greater. But what happens if it's the opposite? What happens when the numerator, so the number in the top, is the same, but the denominator is different? Well, let's say that b is greater than d. Now in this case, the fraction with the smaller denominator is going to be larger. So d is the smaller denominator, so the fraction itself, a over d, is going to be larger. So it's the opposite with the example above. When the numerator is different and the denominator is the same, larger numerator is larger. But when the denominator is different and numerator is the same, the smaller denominator is larger. And so again, let's think of it using the candy example. So we have 20 candies, but since the numerator, or the number we're dividing, is the same, let's say we both have 20 candies. But then I want to give it to 5 people, and I want to give it to 1 person. I want to give it to 2 people. And so this is the number that we're dividing by. So these are the denominators. 20 divided by 5 is going to be 4. So each person is going to receive 4 candies each. But when you're only giving it to 2 people, each person is going to receive 10 candies each. So when the denominator is smaller, you divide by less, so the result becomes larger.
And so before we go into mixed numbers, we want to talk about improper fractions and mixed numbers. So improper fractions are in the form of a over b, and so it's going to be like 27 over 6. So the numerator is bigger than the denominator usually for improper fractions. Now as for mixed numbers, we have a whole number and then we have our fraction. And our fraction is usually like where the denominator is larger. So the fraction is not yet a whole number. It's not greater than 1, but we have a whole number in front. So what the mixed number tells us, so as the name states, it's a mixed number. It's a mix of a whole number plus a fraction. And so what the mixed number tells us is that it has however many number of whole numbers it has. So I know that sounds confusing, so I'll just write down an example. So for example, if we have 2 and 3 over 4, this indicates that it has 2 wholes. And we know that 1 whole is 4 over 4 because 4 over 4 is 1. So that means we have 2 of 4 over 4, and we have a 3 over 4. And so that is going to translate to 8 over 4 plus 3 over 4, which is going to be 11 over 4. And so an easy way to convert a mixed number into an improper fraction, because sometimes it's easier to work with improper fractions when we add or subtract, is you multiply. So now that you've understood how to convert, what you do is you leave the denominator. So you leave the denominator, and then you multiply the whole number in the denominator. So that's going to be 2 times 4, which is 8. And then you add the original numerator, and so that's going to give you your improper fraction. And so now then we should also learn about vice versa and what we should do when we convert from improper fractions to mixed numbers. So for example, if we have an improper fraction like 27 over 6, you first want to figure out a multiple of the denominator that is closest to the numerator but is still smaller than the numerator. So for example, a multiple of 6 that is closest to 27 and is smaller than 27 is going to be 24. So 6 times 4 is 24. And that's going to be the smallest and closest to 27. Then we know that we still have 3 over 6 missing because 27 over 6 minus 24 over 6 is going to be 3 over 6. And so that is going to be, so this combination gives us 27 over 6. But then we know that 24 over 6 is 4. So that is going to be our whole number. And then we simplify this fraction into 1/2, and that's going to be the fraction portion of our mixed number. And so, yeah, If we try the trick to convert mixed number into improper fraction, leave the denominator, multiply, and add. So it's going to be 9 over 2. And so some of you guys might wonder, oh, 9 over 2 is not 27 over 6, but that is due to simplification. We multiplied by 3 for the denominator, also multiplied by 3 for the numerator, so those are equivalent expressions. And so that is how we change from improper fractions to mixed numbers, and from mixed numbers to improper fractions. Now that we're going to talk about addition and subtraction for fractions, we're going to go over some rules for fractions. And so if we have the same denominator and we want to add, then we keep the denominator because it's the same, so it's a common denominator. We don't need to look for a common denominator because it's already the same. And so we're just going to add the numerators together with one common denominator. Also the same for when we subtract. If there's a common denominator, we keep that denominator and only work with the numerators. Now this is when it's just a regular fraction, like written in the form a over b, whether it's improper or proper. But then when we have mixed numbers, like a whole number and then a fraction, how do we add or how do we subtract? And so there's an easy and basic way of adding and subtracting mixed numbers, and in the lesson we're going to learn about more ways to subtract and add. But what I think is the easiest way is you separate the whole numbers and fractions. So for example, if one mixed number is 2 and 3 over 4, and we want to add it to 6 and 1 over 4. What I mean is you want to separate the whole numbers. So we're going to consider 2 and 6 separately as to 1/4 and 3/4. And so 6 and 2 are whole numbers, so we're going to add those together. So we have 8 for whole numbers. Then for fractions, we have 3/4 and 1/4, and when we add them together, it's going to be 1. And then we add the sum of the whole number and add the sum of the fractions. And so we get our final sum. Now, another example is when the fractions don't really come out to be a whole number. So it can be like 9 and 7 over 15 plus 2 and 2 over 15. Now again, we're going to think of the whole number separately. So 9 plus 2 is 11. And when we think about the fractions, it's 7 over 15 plus 2 over 15, which is 9 over 15. We can simplify this by dividing both the numerator and the denominator by 3. So we can simplify it into 3 over 5. And so we're going to combine 11 and 3 over 5. And we can write that out as 11 and 3 over 5. Now just for clarification, we can write this as an improper fraction as well, based on what we learned last class. So keep the denominator, multiply the whole number in denominator, which is 55, and then add the original numerator. And so the way to write that as an improper fraction is 58 over 5. And now let's look at some more problems that involve addition and subtraction of mixed numbers and fractions. And so for example, if we have mixed numbers 6 and 5/7 plus 2 and 4/7, first we're going to add the whole numbers together. So we add 6 plus 2, and that gives us 8. And then we're going to add the fraction together. So we're going to do 5 over 7 plus 4 over 7, which gives us 9 over 7. And that is equal to 7 over 7 plus 2 over 7. So that's 1 and 2 sevenths. So we're going to add 8 and 1, the whole number, so it gives us 9. So we're going to get 9 and 2 sevenths in total. And so it says if we get a fractional part that is greater than 1, greater than or equal to 1, we aren't done yet. So the fractional part of a mixed number should always be simplified and less than 1. And so we're going to do some more practice problems. And so for this question, we're first going to add the whole numbers together. So we're going to do 6 plus 4, which gives us 10. And then we're going to add the fractions together. And that's going to give us 8 over 11. So we're going to write 10 and 8 over 11 as our answer. And then for the next problem, we have 5 and 2 sevenths plus 6 and 3 sevenths. So again, we're going to add the whole numbers together to get 11. Then we're going to add the fractions together. And so we're going to have 11 and 5 sevenths. Then for problem number 97, again, we're going to add the whole numbers together, so that gives us 12. Then we're going to add the fractions together, so we have 4 over 13 plus 7 over 13, and so that is going to be 11 over 13. So in total, we're going to get 12 and 11 over 13. Now for problem 98, again, we're going to add the whole numbers together. Then we're going to add the fractions together. And so that's going to be 3/5. So we get 3 and 3/5. Then for our next problem, again, add our whole numbers together to get 12. Then 6 over 11 plus 9 over 11 is going to be 15 over 11. Now 15 over 11 is 11 over 11 plus 4 over 11. So that is basically going to be 1 plus 4 over 11. And so we're going to add the whole numbers together. So we get 13. And then we're going to have 13 and 4 over 11. And then for problem 100, I want you guys to try solving this on your own. So I'll give you guys about 1 minute to solve problem 100 on your own. And then we'll go over the solution together. And so we're going to go over the solution now. So again, we're going to add the whole numbers together. So 2 plus 8 gives us 10. When we add the fraction together, that gives us 9 over 9, which is equal to 1. So we're going to do 10 plus 1, which is equal to 11. And so we're going to move on to our next set of practice problems. So again, we're going to add our whole numbers together, which gives us 5, and then add our fractions together. That gives us 6 over 5, which is 5 over 5 plus 1 over 5, which is 1 and 1/5. So we're going to add the whole numbers together, which is 6. So our final answer is going to be 6 and 1/5. Then for problem 102, again, we're going to add the whole numbers together. That gives us 12. And adding the fractions together, that gives us 3 over 5. So we have 12 and 3/5. And so I want you guys to try solving 103 on your own, because that is also where the fractions result in additional whole numbers, if that makes sense. So when you add the fractions, that's gonna become a mixed number. So I'll give you guys about 1 to 2 minutes to solve this problem on your own, and then we'll go over the solution together. And so we'll go over problem 103 now. So again, we're going to start by adding our whole numbers together to get 11. And then we're going to add our fractions, so it's 10 over 6. That can be written as 6 over 6 plus 4 over 6, which is 1 plus simplify the 4 over 6 to 2 over 3. And so we're going to add the whole numbers, 11 plus 1 to get 12. So we're going to get 12 and 2 over 3. And then I also want you guys to solve problem 104 as well. So I'll be giving you guys 1 to 2 minutes to solve that as well. And so if we solve problem 104, we're first going to go in by adding the whole number. So we get 29, and then we're going to add our fractions. So that's going to be 25 over 19. And we can write this as 19 over 19 plus 6 over 19. So that's going to be 1 plus 6 over 19. And so adding the whole numbers, we have 29 plus 1 plus 6 over 19, which is 30 plus 6 over 19. And so we're going to have 30 plus 6 over 19. Or 30 and 6 over 19. Then for problem 105, we have 5 fractions. So we're first going to add the whole numbers together. So that gives us 21. Then we're going to add the fractions together. That's going to be 21 over 8. And so that is going to be 8 over, well, that's going to be 16 over 8 plus 5 over 8, which is 2 plus 5 over 8. So adding the fraction together, we have 23. So it's going to be 23 and 5 over 8. And I also want you guys to solve question 106 as well. So I'll give you guys about 3 minutes to solve this problem. And so again, we're going to start by adding the whole numbers together. So we get 36, then we add the fraction together. And that gives us 26 over 13, which is 2. So we're going to add 36 plus 2, which gives us 38. Now we're going to look at some word problems. Mr. Jones uses 1 2/3 gallon of blue paint and 2 2/3 gallon of red paint to paint his garage. How many gallons of paint does he use? So we're going to add 1 2/3 plus 2 2/3. So again, add the whole number together. That gives us 3. Then we're going to add the fraction together to get 4 over 3. And that is basically 3 over 3 plus 1 over 3, which is 1 plus 1 over 3. So in total, we're going to have 4 and 1 over 3. So it's going to be 4 1/3 gallon. Next, what is the perimeter of an equilateral triangle whose sides are 2 3/4 inches long? So it's an equilateral triangle, so we're going to add this 3 times. And so that's going to be, first we're going to add our whole number, which gives us 6. Then we're going to add our fractions together. And that gives us 9 over 4, which is 8 over 4 plus 1 over 4, which is 2 plus 1 over 4. And so 6 plus 2 plus 1 over 4 is going to give us 8 1/4. It's going to be 8 1/4 inch. Now for problem 109, it says, what is the perimeter of a rectangle with width 5 6/7 inches and height 2 4/7 inches? So we're going to add 5 6/7 twice. So add that twice, and then we're going to add 2 4/7 twice as well. So first, we're going to add the whole numbers together. That's going to be 14. And then we're going to add the fractions together. That's going to be 20 over 7. So that we can write that as 14 over 7 plus 6 over 7, which is 2 plus 6 over 7. So adding the whole numbers together once more, that's going to be 16. So we're going to have 16 6/7. So it's going to be 16 6/7 inches. Now we're going to talk about subtraction. So subtraction is also really similar to what we did for addition. So it says, what is 7/9 minus 5/9? Again, since the denominator is the same, we keep the denominator and only play with the numerator. So it's going to be 7 minus 5, which is 2/9. And also we can show the subtraction on a number line as well. So for example, if we start at 7/9 and each space is worth 1/9, then we're going to move 5 times, which brings us to 2/9. And so for problem 110, it's going to be same denominator. So 4 minus 1, it's going to be 3/8. So if you start at 4/8 and one space is worth 1/8, we're going to subtract it once to bring us to 3/8. For 111, we have denominator 5, and numerator is going to be 3 minus 2, which is 1/5. Now in this case, we start at 3/5, and each space is worth 1/5, so we're going to go twice, and that's going to bring us to 1/5. And for 112, the denominator is going to be 9, and numerator is going to be 8 minus 7, so it's going to be 1/9. Also, on the number line, we have 8/9, and each space is worth 1/9, 1/9, so we're going to go 7 times, which brings us to 1/9. Now for problem 113, denominator is going to be 6, numerator is 5 minus 4, so it's going to be 1/6. Now we start at 5/6, and then one space is worth 1/6, so go 4 times, and we get to 1/6. Now I want you guys to solve problem 114 on your own, so I'll be giving you guys about 2 minutes to solve this problem. So I want you guys to check both algebraically and on the number line. And so here, algebraically, our denominator is going to be 11, and our numerator is going to be 10 minus 6, so it's going to be 4/11. On the number line, we start at 10/11. Each space is worth 1/11, so we're going to go 6 times. And that's going to bring us to 4/11. Then we have 8/10 minus 5/10. Again, denominator is the same. 8 minus 5, so it's going to be 3/10. We start at 8/10. Each space is worth 1/10. So if we go 5 times, it's going to land at 3/10. So we're going to do some more practice algebraically. Our denominator, again, is going to stay at 13 because it's the same for both. It's going to be 9 minus 1, which is 8/13. Same thing, so it's going to be 7/9. Our denominator is the same, so we're only going to use the numerator, so it's going to be 3/12. And we can simplify this into 1/4. Now this, again, denominator is 8, numerator is 7 minus 5, which is 2, and we can simplify into 1 over 4. Then for this, our denominator is going to be 15, and our numerator is going to be 22 minus 13, which is 9. We can simplify this by dividing both the numerator and the denominator by 3, so it can be simplified to 3 over 5. Now for problem 121, our denominator is going to be 9, and our numerator is going to be 20 minus 14, which is 6. So we can simplify this into 2 over 3. And so we have some practice problems. So it says the weight of a dime on Beast Island is 2 over 25 ounces. The weight of a Beast Island dollar coin is 7 over 25 ounces. How many ounces heavier is a Beast Island dollar coin than a Beast Island dime? So we're looking for the difference, so we're going to subtract. Since the denominator is the same, we're only going to manipulate the numerator, so 7 minus 2 is 5. And dividing both the numerator and the denominator by 5, we can simplify into 1 over 5. So it's 1/5 ounce heavier. Now for problem 123, we have the distance from point A to point B on the line below is 25 over 16 inches. From A to C is 33 over 16 inches. And so to find the point from B to C, we're going to subtract 25 over 16 from 33 over 16. And so that's going to give us 33 minus 25 over 16, which is going to be 8 over 16, which is 1/2 inch. Now our final question is, Alex swims 17 over 10 miles in the morning. How many more miles must Alex swim in the afternoon if he wants to swim a total of 25 over 10 miles for one day? So we're going to subtract. So same denominator, and the numerator is going to be 8. So we can simplify that into 4 over 5. So it's going to be 4 over 5 miles more. And that is it for today's class, and I'll see you guys all in the next video.